Okay, so let's take a look at a four-variable Karnaugh map in which we have a function f, which is in numerical form. So these are the min terms of that function, and these are the don't cares right there. I'll show you what those mean in the Karnaugh map in just a moment. Our goal is to find the minimum solution and therefore the smallest circuit. When you have a Karnaugh map like this where AB is along the horizontal axis and CD is along the vertical, you can count in decimal in the upper right hand side kind of as a reference so that it can help you fill in these numerical values in a moment. All right, so this cell corresponds to the decimal number 0. This corresponds to 1. Now the way that you justify that is if you look at the values of A and B, it's 0, 0, and 0, 0. Obviously that's the number 0 in decimal. And then you go 0, 0, 0, 1. That's the number 1. You will notice that the number 2 actually goes down here because of the flip-flopping of the last two rows on the Karnaugh map. That makes it so that we have the number 3 right there. 4 appears here. 5. 6 is down here, and then 7. 8 jumps way over here. 9, 10, 11. 12 goes up here. 13, 14 down at the bottom, and 15. Seems like it's in an odd place, I know, but it's right there on the lower right-hand side. Now, what this numerical form tells you is where the ones are, and so let me maybe change ink on this one. Go ahead and hit save, and then come back and use a different color ink for these ones. So you're going to have a 1 where it's the number 2, 3, 4, 7, where's 9 at? Right there, number 9, and then the number 11, 12, 13, and 14. These right here are the don't cares, which means it doesn't matter if the circuit gives you a 1 or 0 for the output. So for that, we'll put an X for don't care. Make that a little bit neater. X for the don't care. And number 10, let's see, where did that go? Right here. And also number 15 is right here. So what you want to do here is fill in the rest of these with zeros and look for groups of 1. And remember, you're looking for groups of 2, 4, 8, 16. And the biggest group possible is what you're shooting for. And you can overlap. And you just kind of stare at this and you see that, well, maybe I'll go back to using the black ink for this one here. All right, so I see a group of 4 right there. And notice that I use the X because we don't really care if that one's a 0 or a 1. So if an X helps you, you want to include it. But if it doesn't, then you don't need to include it in a circle. I also see another group of 1 right here as well. Okay, so those are 2 groups right there. Maybe I'll change to a different color to focus on these other ones. So go over here, maybe select another color like, no, yellow for that one. And then for this one, see if yellow will show up. Have a group of 4 horizontally like that. That's allowed. I guess I could do a group of 2 right here. And then I have just one left over. There's 2 things I can do with that one. Let me save it, pick one more color. Magenta. I could either group it like this and do a wraparound and include the X, or what I can do is do it this way. Either way, it's going to be a minimum solution because it's not a choice between 2 and 4 in a group, it's a choice between 2 and 2 in a group. So it looks like there would be multiple solutions for this circuit that would give you the equivalent number of terms and literals. Alright, so if we go for this magenta one first right there, you see that A and B stay 0 for that one. So I'm going to put A prime and B prime for that one. And D changes right there. So I can exclude that one, but C stays in the 1 state, so I'll leave it like that. Alright, let me hit save and go back and maybe try the yellow one now. This one right here, I'm going to put an OR like so, and you can see that for that row, A and B are all changing, but C and D stay in the one state. So I'm going to put them there with no primes. I got another yellow circle, which is up here at the top. And that corresponds to C prime and D prime, but also B as well. You see that B stays on in going through those cells right there. All right, let's do one more, I guess. Well, it looks like we have two more. Go over here, change the ink color. So I have this one right here and that one right there. Now these are going to have two terms in it because I have a group of 4 in a 4x4, and you'll see that this one's going to be A and B because going through all 4 of those cells, A and B are the only ones that stay the same, and they stay in the 1. They have a value of 1 in all 4 of those cells, so we leave them unprimed in our equation. And lastly, we can see down here for this group of 4 that A stays high and D stays high over here. All right, so there is our simplest circuit, or simplest equation from the Karnaugh maps. Of course, we could try things like using NANDs and NORs, or exclusive ORs, or even De Morgan's theorem. But this is the simplest you can get, I believe, from a Karnaugh map.